Hey guys, today we will be simplifying radicals. In the video before this, we went over basics of radicals and some vocab. Today we will go over more specific basics that may even be questions on a test by learning how to simplify radicals. So there are two ways to simplify a radical. Most people like one more than the other, but we'll go over both. The first way to simplify is by finding the perfect square. So if we had the square root of 75, that just means the square root of x times the square root of y. So let's look at what it could be. One possibility is the square root of 25 times the square root of 3. Well, the square root of 25 is just 5. So we would bring the 5 out of the radical symbol since we found the square root of 25, and all we'll be left with is the square root of 3. So now it's 5 times the square root of 3, which is just 5 square roots of 3. The second way to simplify a radical is by using prime factorization. The way you do this is by finding two factors and then simplifying those factors until all you're left with are prime numbers. And then you would find pairs and try to bring them out. It's not as complicated as it sounds, so stay with me. Let's see. The square root of 75. First, we find the factors of 75. We could pick any factors, so let's pick 5 and 15. Now that we have the factors, are all of them prime? No. 15 can be broken down into 5 and 3. So now all of our numbers are prime. So now we would circle our prime numbers just to keep it a little bit more organized, and we would try to find our pairs. There are two 5s, so the 5 would come out of the radical sign, and the 3 would stay in. Think about it this way. The parents of the numbers inside the sign won't let their kid go out and play unless they have a friend with them, and their friend has to be the same number as them. So since there are two 5s, 5 can go out and play. But since there's no other 3, 3 has to stay inside. As you can see, our answer was the same no matter what way we did. I will simplify with the second method, but you can do whatever you like better. So let's do the square root of 32. Let's find the factors, which will be 2 and 16. 2 is a prime number, so we can circle that. And 16 can be broken down into 4 times 4. 4 can be broken down into 2 times 2. We know that 2 is a prime number, so we'll circle all of them. And now we need to find our pairs. There are two 2's and another pair of 2's. And then we have one 2 left behind. So now the 2 is going to come out and play, but since we have two pairs, two 2's will come out. So now we're going to have 2 times 2 square root of 2. 2 times 2 is 4, so it would be 4 square root of 2. Let's simplify cube roots. It's the same as simplifying square roots, except for the fact that you have to find trios and not pairs. Let's try. So cube root of 8. Well, 8 can be broken down into 2 and 4. 2 is a prime number, and 4 can be broken down into 2 and 2. 2 is a prime number. So now we gotta find our trios, the same number 3 times. Well, the same number 3 times we see there is 2. So the cube root of 8 is 2. The cube root of 16. So let's break it down. We know that 4 times 4 is 16, but also 2 times 8 is 16. 2 is a prime number, and then 8 can be broken down into 4 and 2. 2 is again a prime number, and 4 can be broken down into 2 and 2. 2, a prime number. So now we need to find a group of 3. We can see that there are 3 2's, and then 1 2 left behind. So now we would bring the 2 out and leave 1 2 in the radical sign. And now we're going to put our 3 in the index. So our answer is 2 cube root of 2. Let's do some practice problems. Simplify the square root of 48. Well, 12 times 4 is equal to 48. 12 can be broken down into 3 and 4 can be broken down into 2 and 2. 2 is prime, and 4 can be broken down into 2 and 2. And 3 is prime. So now we gotta find our group of 2, our pairs. Well, we can see that there are 2 2's and another pair of 2's. And then there's 1 3. So now we would have 2 times 2 to the square root of 3, which is just 4 to the square root of 3. Let's do the cube root of 56. 56 can be broken down into 7 and 8. And 8 can be broken down into 2 and 4. 7 and 2 are our prime numbers so far, and 4 can be broken down into 2 and 2. Or again, 2 is our prime number. So now we need to find groups of 3, which is just 2, and 7 left alone. So it would be 2, 7, and then we'd add our index. What if we had something like 3 square roots of 144? How would we simplify that? Well, we would simplify what's in the radical sign, and we would get 12. And since 3 square roots of 144 just means 3 times the square root of 144, we would multiply our answer, what we got, which is 12, by 3. We do this because the square root of 144 is just 12, because 12 times 12 is equal to 144. So we do 3 times 12, which is just 36. So 3 square roots of 144, or 3 times the square root of 144, is equal to 36. Let's practice. -2 square root of 45. 45 can be broken down to 9 and 5. 9 can be broken down to 3 and 3. 5 is prime, and so is 3. We see our pair, which is 3. So -2 times 3 square root of 5. That would be -6 square root of 5. Let's do one last practice. 8 cube root of 1000. 1000 can be broken down into 10 and 100. And 10 can be broken down into 5 and 2. 2 and 5 are prime. 100 can be broken down into 10 and 10. And again, 10 can be broken down into 5 and 2, where 5 and 2 are prime. 5 and 2, where 5 and 2 are prime. So now we need to find our trio. We can see there are 3 5's, so that would be our trio. And there are 3 2's, so that would be a trio. So then what we would get is 8 times 5 times 2, not to square root of anything, oops, and 8 times 5, which is 40, times 2, which is 80. So 8 cube root of 1000 is just 80. That's how to simplify radicals. Thanks for watching, and I hope I made math a little less hard for you. Catch you later. Bye!